We're good to go? All right. You guys are in the place to be. I heard this was sold out last week, so I'm excited. So, good afternoon. Welcome to our talk on Lift and Evolve, how we look at migrations, and hopefully you learn some things. Really want to spend some time talking more about the Evolve part, but really want to talk to you about migrations in general. So my name is Chris Resch. I'm from Second Watch. I'm joined by my colleagues Ryan Kennedy and Chris Nolan, who are the smart guys in the room. So they'll talk about what you're all here to hear about, which is more about the Evolve part of migrations. So a little bit about me. I spent about 17 years working as a director of IT, running some large IT operations for a large media conglomerate, and then spent a couple of years working for AWS, working on some of the largest migrations that we were doing at the time, and now working with Second Watch, a premier partner of AWS. So really want to spend, what you should expect out of this session is talk about the lift and shift migrations, talk about the lift and evolve, give you an automation example, and talk about business outcomes, because I think business outcomes are probably the most important part when you're doing any of these technical transformations. Anybody know what movie this is from? Come on, who is it? There we go. So I just look at every presentation. I don't know if you guys see, I get these cheesy clip art or stock photo type stuff. So when they came out with this movie and they open licensed it, I just throw it in every presentation. So, the cheesy handshaking photo you always see in presentations, specifically around sales. But really what we're saying here, migrations are technically easy, but they're technically easy if you have everything aligned the right way. You've got the right OS, you have a perfect kind of scenario where things are, the technical part of it moving and migrating to AWS, it's pretty easy. There's a lot of tools out there that'll do it for you, some free, some paid, but that's the easy part. What we really see a lot is, migrations are easy, but change is really hard. How many here have undergone a migration of any type within AWS? All right, you guys should be up here talking. No, that's good. So what we see, change is hard, and it's really, it's the hardest thing in an organization, whether it's the people, whether it's the process, whether it's the technology. You look at prioritization. CEO tells, the IT department, hey, we want you guys to save money. Oh, and by the way, we need you guys to launch new products. So how do you prioritize that? So the change is hard, and it's not something that's going to happen overnight, but there's a tremendous amount of change going on there. This is my 5th reInvent, and it's amazing just to see. You guys saw today, just walking up here, how many people are coming in here. Started out with 6,000 people, so it's just this constant change, and there's just constant motion. And to keep up with the pace of innovation that AWS is innovating at that's a daunting task. I don't even know what the number was this year of product enhancements, product releases. It's just a lot to stay up on. So we look at change as being really just a critical component of your migrations, and it's a hard thing to do. So I'm sure those of you who have done migrations have really looked and followed this thing called the 5 Rs. Rehost, real easy, cheap, migration velocities fast, you can get over pretty quickly. Any of the 4 below that, the refactor, the revise, the rebuild, the replace, those are things that have varying levels of difficulty. There's many changes there. There's higher cost, and some, quite frankly, just might not be appropriate to move. This is what I would say for those of you that are looking to do migrations, for those of you that are in the business of migrations, this to us is the best practices. We've iterated on this quite a bit over the last couple of years, and we believe these are the best practices for your journey. It's amazing to me, though, when we look at the migrations and kind of where we have been over the last few years. We and I think of us all as a community, whether you're at AWS, you're a partner, or you're a consumer of AWS, our community has only been really together for a couple of years. We've only been doing migrations for really 3 years. And if you think about that, that's just fascinating. And it fascinates me because, there's all this hype, people are migrating, but we've only really started doing mass migrations, full data center closures, 2013, 2014. I mean, it's a couple of years ago. So it's really incredible. So we, and a lot of partners that we work with, they basically are using the same kind of methodology. And we'll dive in a little bit deeper on some of these points here, but when we think about, doing migrations, assess, design, build, kind of at the front end. You could do them in parallel. You can do them serially. You can do them any which way you want. Your journey is your own. When you're moving to the cloud, your mileage may vary using this type of stuff. You may want to do things a little bit differently, but the way we look at it, we build, we design first, we build, we secure all the way through, and then it's really those two functions of operate and optimize, which we'll get in a little bit deeper as Chris and Ryan talk. When we get into that, that's really where you start seeing kind of the differences of things you could take advantage of. Big thing for us, one thing that we stress, we go back to that first slide with Vince Vaughn, migrations are easy. We believe that the technical migration part of this journey is an easy part here. The assessment is, to us, the most critical component of any cloud journey. Doing that assessment, and there's a lot of tools, you'll hear, and you guys are gonna be on the expo floor, and you're gonna see a ton of vendors out there, and they've got these great discovery engines, they've got these incredible ways to assess current, application estates. But I will stress to you that it's not about the technology that does that assessment, it's about, I kind of make it akin to what I think we are on kind of this part of the ecosystem, is being a cloud therapist. So what I mean by that is interviewing, there's a lot, we go back to the change portion of this. There's so many things that are changing. People are afraid of their jobs. There's application developers that are like, wait a second, you're assessing my application with the cloud, but it's running fine over here. So we really stress the importance of not only using the technology discovery tools, but interviewing the folks that are impacted, whether they're the infrastructure folks, whether they're application developers, whether they're business owners. Take that information, validate it against the stuff that you automate, that you get from those discovery engines, and then that's when you can build your migration plan. And I think, we always get back to this, measure twice, cut once, over-communicate. Over-communicate your desires, your plans, everything that you're working on, over-communicate it to business owners, over-communicate to your CEO, tell your wife, tell your boyfriend, whoever, tell everybody about it, because communication, I think, is really key when you start looking at doing these migrations. What is a lift and shift migration? Many of you already know this. What I really want to do here, but I wasn't allowed to, was you guys ever see that Planet Fitness video, commercial? I lift things up and put them down? That's lift and shift. So you're basically taking your current environments, you're moving them over, you're changing things a little bit, but they're inherently not taking full advantage of cloud native services, which we'll get into in a little bit here. This is what we use as our cloud factory. It kind of goes back to what our best practices here. It's a methodology that we've used with a lot of our clients. We see a lot of others, even customers that are do-it-yourselves, use the same type of thing. Again, analyze up front, assess, automate, build these migration waves. The migration part will be easier. One thing I'll leave you with before I turn it over to Chris and Ryan is the way we view a lot of migrations. It's not about, we get back to it's not about the technology, but it's really not about, all the different tools out there. We've built a methodology, and I believe that anybody here can do the same thing, is we kind of take a little bit from the AWS philosophy where things are loosely coupled. So whatever's the best tool for the job, we can make work as long as our process is a repeatable process. So we look at our arsenal of tools that we use, that we utilize when we do a migration, and we we use the most appropriate tool for the environment we're working for. We're not always a hammer looking for a nail. So that's always something that I think can be daunting as you're looking at all the vendors out there that do lift and shift migrations for you. With that, I'm going to turn it over to Chris Nolan, who will talk a little bit more about the Evolve, and we'll get into some demos.
Thanks, Chris.
You got it.
Welcome. Thank you for joining us. My name is Christopher Nolan, technology director, not movie director. So while I can't talk to you about Batman or Interstellar, I can talk to you about DevOps and the cloud. I've been working with Second Watch for 3.5 years now. Most recently doing product management, but in my first 2.5 years with Second Watch, I worked in professional services. And I led a team who worked with some of our largest enterprise clients. And obviously these clients were moving to the cloud. In addition to moving to the cloud, they were looking to evolve their practices and take on a new approach to delivering software to their customers. And so we're going to talk about that today. And you may be thinking, oh, this is the same DevOps stuff I've heard over the last 6, 7, 8 years, but it's always worth reviewing. And as Chris said, talking as a community about how we can make things better and how we can move faster in the cloud. And even, Amazon is evolving their practices to take on a DevOps model. If you looked at the well-architected framework, they released an update last week. And that update added an additional pillar. That additional pillar is operational excellence. And if you look at the best practices underneath that pillar, you're going to find many of the things that we're talking about today. A show of hands, how many people have DevOps in their title or work somewhere that has a DevOps team or has DevOps folks, and it's a group of people who do it or a title, and I have my hand up as well. I've worked in a place where I was director of DevOps, but that's really not what DevOps is. It's not a person, it's not a tool, it's not a team. It's the application of agile practices on top of infrastructure. But it does give us a framework for how to talk about it, so we use the word DevOps. But ultimately, DevOps is about bringing business value faster. How can you get things into your customers' hands faster? When we talk to CIOs of some of the largest enterprises, they tell us two things, or their two main goals, or two main motivations for moving to the cloud. The first is saving money. They want to cut costs. The second is they want agility. And by doing a lift and shift migration, you're going to achieve both of those, but it's a gradient. So on the cost savings, you're going to save money by not having to worry about heating and cooling. You're going to save money by not having to worry about racking and stacking. On the agility side, you're going to move faster because when you want to do something new, it's easy to do. It's easy to spin up a server. It's easy to spin up new services. But to really move up that gradient and save more money and deliver business value faster, you have to adopt a new model of doing things. So why should we care about DevOps? There's a number of reasons why we should care about DevOps. The first is quality. We want to deliver quality software, services, and features to our customers. The second is about reducing time to market. You want to go from idea to production as quickly as possible while still ensuring quality releases and quality software. You want those releases to be reliable. I've been doing this for 20 years, and I'm sure some of you have been in this industry for a number of years, and you think back to that time where you opened a change management ticket. It was going to be a 2-hour change. The change advisory board approved it, and you go in on Friday night to make this change, and 2 hours turns into 4 hours, turns into 6 hours, turns into overnight, turns into, okay, I got it working just in time for the users to come online. But that's not a scalable model, and it doesn't allow you to deliver business value faster. You want to do smaller changes more often. We should care about DevOps because we care about the customer. We're focused on the customer, and we're focused on customer satisfaction. You should also care about DevOps because you want to build the right thing and you want to fail fast. And both of these tie back into customer satisfaction. So if you are able to do small incremental changes quickly, you're able to get features into your users' hands and get them using them quickly. But But you're also able to fail fast so that when you do one of those releases and something fails, you can revert it or you can iterate on it quickly. And the other reason we should care about DevOps is because we're all in digital business. Whether you think you are or not, you are a digital business, or you're not going to be around. You can look at companies like Hilton or Starwood who were not in the digital business. They were in hotels, but Airbnb came around and they had to up their game. Same thing is true with taxis. You can hail a taxi now with an app on a phone. Taxi companies weren't digital companies before, but Uber and Lyft have forced them to go there. So whether you work in finance or healthcare or any industry, the ability to deliver software quickly will impact where you're going to be in the future. And you have to do that. You have to evolve, or you're not going to be around. So when implementing a DevOps model, how do you know that you've been successful? Well, it's like magic. Things just work. It's the way you test your software. It's about testing early and often. It's about the way you test your infrastructure as code definitions and testing those before they go into production. It's about the way you fix problems quickly. It's the way you push changes to production many times a day. It may feel like magic, but there's more ways to know that you've been successful. So it's not only about delivering software faster. You'll find that folks who adopt DevOps practices and teams that do and companies that do, they're able to recover from failure faster. The 2016 State of DevOps report released by Puppet Labs, they said that teams who are high-performing DevOps teams recover 24 times faster when there's a failure. So to think about that, a high-performing team can recover in 2 minutes, where a low-performing team may take an hour to recover. And that's very important. So it's not just about delivering things faster and moving quickly, it's about fixing things when they break, because they're going to break. Software is written by people, and people make mistakes. So you have to be able to recover from those quickly. It's about deployment frequency. How often are you pushing to production? How often do you have changes going out? And it's also about the change rate and how well those changes work. And finally, it's about deployment lead time. When something has to go out quickly, how long does it take you to get queued up to do that? You'll find that as you implement these practices and change to a DevOps model, you'll be able to recover quickly. You'll be able to push software many times a day with low errors, and you'll be able to do it at the drop of a button, drop of a hat. Now, what are some of the things that you can do in your organization to have folks adopt this sort of a mentality and this sort of a way of doing things? Gene Kim came up with the 3 ways. And the 3 ways are really about how you think about your organization to get to this model. The first way is systems thinking. What systems thinking is thinking about how what you're doing impacts the entire system. It's about thinking about how your change impacts the next person in line who's going to get your artifact and how that impacts them. These are folks who can think about the entire system and care about the entire system. And managers and leaders in a company need to find these folks and put them together on a team so that you have folks who are from software development, folks who are from operations, DBAs, QA testers, working together on a single team and having the developers carry a pager and having the operations folks writing software. The second way is amplified feedback loops. Amplified feedback loops are empowered both by software as well as by process. So in software, it's monitoring. It's your tools that you use to test your software to ensure that when a change happens, that change works. And it's about having those feedback loops work for when there's a failure. So when you have a failure, you try to figure out the problem and not figure out who broke it. And understand how you can not have it happen again. And the third way is through continued education and experimentation. And the third way is important because you need folks who are going to help you evolve and experiment with new things and try new ways of doing things. And the previous 2, systems thinking and feedback loops protect you from those people who are doing experiments. Because when they're doing those experiments and when they're trying new features and services, they're thinking, how is this going to affect everyone else? How is this going to affect the entire system? And they also know that they have feedback loops in place, so when they're doing those experiments and something breaks, they know right away and they can fix it. There is no magic bullet tool or process. You know, it is truly a tool chain of services that allow you to move to a DevOps model. And in this tool chain, there's software for helping you deal with code and how you do development, how you do code reviews, how you do continuous integration. There's build tools to help you build that software, make sure things are merging, and have it alert you when there's a problem. There's testing, both automated and manual tests, and software to enable that. There's the way you package software and create deployable artifacts. There's the way you do releases, the tools that enable releases, both in getting the software out there, but enabling you to do canary testing or A/B testing. There's the configuration management component, which both dictates how you manage your systems, but also how you define your infrastructure as code. And all of these things have testing built into them as well. And finally, there's the monitoring. There's the feedback loops to help you understand when things are working and when things aren't, and gives you immediate feedback. But again, this is hard stuff to do. It's hard to change an organization. You need management whose top-down approach is to achieve these goals. But you can also do it from the bottom up by introducing technologies into your organization that enable your customers and your teammates to work in a DevOps model. And with that, I'm going to hand it off to Ryan Kennedy, who's going to take us from theory to practice with some work we did with one of our largest customers.
Thanks, Chris. And Chris. So, as Resh mentioned, my name is Ryan Kennedy, and I'm a principal architect for Second Watch, utilizing the principles that these guys were just talking about to build highly scalable, reliable, automated architectures is something I'm really passionate about. The project I'm going to describe to you and walk you through and give you a demo of is just one solution that we've come up with for our customers to help them leverage those principles and the AWS cloud to really boost their bottom line. Before we dive in, I'm going to kick off a demo. I'm going to kick off a demo. Now, this is a CloudFormation template that we are going to launch using a shell script, using the AWS CLI, just for the sake of simplicity and speed. OK, there we go. This is the US West region. I'll go ahead and refresh that so you can see we don't have a stack currently running in there other than this 2W Insight stack. OK, so I'll hop over here to the terminal. And we'll kick that off. All right, got our stack ID back. And if we go back over to CloudFormation, we can see the stacks launching. Likewise, we don't yet have any resources in EC2, so that stuff will come up. But while that's running, let's switch back over to the presentation and dive in. All right, so like pretty much all projects, we started out with a business problem. The business problem we had was to develop a solution that provided a service catalog approach to the rapid deployment, also management and governance, of distinct web application platforms to support a multitude of vast and highly fluid digital advertising campaigns for this customer. In order to solve this business problem, we came up with some objectives that we needed to accomplish. The first one was that it needed to be a one-to-many approach, meaning we needed to have a single solution that would service dozens and hundreds of different applications and configurations. It also needed to be easily, reliably able to manage a massive fleet of AWS accounts and instances, actually across hundreds of AWS accounts. It needed to be able to run in what would be considered a masterless mode as a fail-safe, This is in regards to Puppet, meaning that if an agent came online through auto-scaling or just a stack launch, it needed to be able to reliably configure itself quickly without, in the rare event that the Puppet master service was offline or something, without having that availability, it would be able to run in this masterless mode. At the same time, it needed to be able to self-heal. When the Puppet master service came back online, it would automatically recover, bring itself back into configuration. It had to be able to scale at mass, and it had to do it quickly, automatically, and be able to adjust to any change in demands, and do it elastically. It had to come up and go down. It needed to be able to support multiple application platforms and environments. It had to do this, and it had to be able to support both Linux and Windows platforms. The customer desired using open source Puppet to save on the perpetual licensing costs that are associated with Puppet Enterprise, and there were really no compelling features with Enterprise that we felt like we had to have, so that was a very functional part of the equation. It also needed to be flexible and easily extensible for any future growth needs. So as Chris Nolan just mentioned, Clark's third law, we wanted the solution to be sufficiently advanced and indistinguishable from magic. So it was just poof, it worked. But to whom? Primarily this was for our operations engineers and the application developers and application owners who would be utilizing the platform. In order to make that a reality, we had a number of objectives for the solution, a number of architectural decisions that we made. The first one was we were going to use Puppet, open source Puppet version 4. That has all the latest and greatest features, everything we needed, and took advantage of maybe some of the newer and better principles that Puppet's using. It needed to have a multiple master catalog compiler, sort of cluster to handle all of the high availability requirements as well as any horizontal scaling. So it would be able to be fully redundant but also be able to scale horizontally automatically. We accomplished that with auto scaling, the elastic load balancer, and Route 53. The automated, or the build and recovery of any host had to be fully automated. It had to be done so in a very easy and manageable manner. We didn't have the ability to go in and manually correct things. Everything had to be self-healing and fully automated. Policy-based auto-signing is a critical component to this architecture. In a traditional Puppet architecture, even today, you have agents create a certificate request. That gets sent off to the Puppet CA server, which then has to sign that certificate. That has historically been either done manually, which obviously does not scale well and doesn't really fit our DevOps model worth a hoot, or you had to enable auto-signing. Now, the auto-signing was really limited in what it would do. You either auto-sign based on something like a domain name as part of the certificate, matching some value, or you just had it auto-sign everything, which has obvious security implications. So unless you have absolutely watertight access control on your network, that's a pretty insecure solution. Even with secured network access control, it's pretty insecure because you can always have maybe the wrong person on a machine doing something you don't want them to do. Thankfully, Puppet developed this thing called policy-based auto-signing, where you could have the auto-signing piece of the CA offload that certificate request sign to a third-party tool or a script, and we were able to use our own system we built to use things like the EC2 API and other factors to validate the authenticity of these new agents in an automated fashion, so we could scale up and scale down really quickly without having to worry about going in and manually signing certificates, and also not have to worry about the security implications. In addition to that, we had to have something called an automatic node classification. So as new nodes are created, they need to be able to tell Puppet what kind of server it is. Is it a web server or a bastion or what have you? Since this thing was fully automated using CloudFormation, we were able to embed those artifacts inside of CloudFormation and then have the node classification. That's handled by something called roles and profiles. This is taken from a guy named Craig Dunn's roles and profiles methodology he came out with for Puppet several years ago. Go ahead and click the slide here. And so what that does is it provides a workflow within Puppet that allows you to apply a specific set of manifests and modules to an agent based on their classification. In addition to that, we used R10K to do all of the Puppet Master deployment, all of the module and environmental building on the Puppet Masters. This is all done automatically. Also stores our HIRA data. And for HIRA data, we're storing things like business logic and business data and any module parameters that needed to be stored outside of the Puppet modules themselves. So just good modular design. We implemented PuppetDB, and we utilized a multi-AZ RDS instance for that, so it was highly available and fully automated and managed by AWS. In addition to that, there's a RESTful API service that runs on the Puppet Masters and is serviced by ELB. The agents needed to be able to run completely headless because of the really disjointed nature of all these different hundreds of AWS accounts this architecture is running across. So we had to make sure that all these agents were running headless and self-healing and kind of self-manage themselves. One of the more key components is that it had to run securely over public internet space. So as I mentioned, all these AWS accounts were completely disjointed, so no VPN, no direct connect, no VPC peering. There's really no network connectivity between them. It all happens over the public internet. So all that traffic had to be encrypted naturally. But this had major implications for making sure that we had firewalling in front of the Puppet Master servers, in addition to the client server certificate verification. But it also had, it meant we had to, what was the other thing? Oh, yes. The agent cleanup piece was a critical part of that as well. So in addition to being able to spin up new agents, we had to be able to automatically clean up when agents terminated, and this is pretty frequent due to the ephemeral nature of cloud computing and even sometimes the short lifespans of digital advertising campaigns. There's quite frequently you'll have instances come up and down very rapidly, and you have this cruft of Puppet agents you need to clean up after, and so we have an automated tool that goes in and manages that. Also, if you're doing any sort of continual integration or continual delivery tools, a lot of times those will generate, for testing and things like that, those will generate a lot of up and down traffic that you have to clean up after. In addition, we have an auto parking tool that we created for the customer that creates, or it brings the test and dev environments up and down on a regularly scheduled event. So, during regular business hours during the week and the weekends, it kicks off, and then you end up with a lot of these extra agents that have to be cleaned up. So to implement this solution, we utilized no less than 20 different AWS services. This included the usual suspects, things like S3, CloudFormation, VPC, EC2, CloudWatch, Route 53, IAM, RDS, ELB. Those are all used, as well as RDS, Lambda, CloudTrail, AWS Config, SES, SNS, and Elasticache. And in addition to that, we utilize some of the latest and greatest offerings, newer tools like ACM, EFS, Code Commit, and Code Deploy. So this is basically just a swath of all the different AWS services we use to deploy this architecture. All right. Okay, so our stack is completely launched. That's great. All right. No surprises, just want to make sure. Okay. Okay, So this is a high-level diagram of the entire architecture that we developed and created. I apologize if this is a bit of an eye chart for anyone. It's definitely scaled down a bit, but we wanted to capture, the architecture as succinctly as possible here and be able to cover that with you. So starting in the middle, we have, you guys able to see that? I cannot. In the middle of the graph, we have an AWS account that is the central account that hosts all of the Puppet resources. Everything in there is managed by CloudFormation with exception of a few S3 buckets and the ACM certificate, which isn't currently in CloudFormation, but the buckets we needed specific naming on, things like that. And if we start at the top, we've got, within that VPC, we have 2 availability zones, so everything's fully redundant, loaded across 2 availability zones. The first thing is the Puppet Master ELB. Right below that is the Puppet Dashboard ELB, which is serviced by ACM for its SSL certificate. Below that, we have the Puppet CA server. Now, you'll notice that in the Puppet CA server, it crosses both availability zones, and on the right, there's a very faint outline. That is to represent that it's running in this, what's considered a poor man's HA. And what that means is it's running in an auto-scaling group with a min, max, and desired value of 1. This ensures that we always have a Puppet CA server running and only one. So if there's a problem with a service or the EC2 instance goes down or the availability zone has a service interruption, it'll automatically fail it over and run in the other availability zone. The one key to that is it has to be able to fully recover and build itself automatically, obviously. The certificates, the CA certificates that it has signed for agents are stored or offloaded, backed up into an S3 bucket, and then during launch, if it sees any of those, it'll actually create or copy them over. And this has worked pretty flawlessly. We've actually demonstrated it in production a few times, just terminated the instance and then watched it come up, completely recover, and have everything on it and never skip a beat. Below that is the same kind of poor man's HA for a Bastion server. It doesn't have any of the hard requirements for certificates or anything like that, so it's very simple to just have it relaunch. It does so, utilizing Puppet modules and normal configuration. Below that, we have a pair of NAT HA servers. We could have used the managed NAT service that AWS provides, but this was built prior to that, so I think that just came out last year. So that's an area we could change eventually if we decided to, but this is working great as is. Then below that, we have the Puppet Dashboard servers that are behind the ELB, running in a multi-AZ auto-scaling group as well. Below that's the Puppet Master catalog compilers that are running multi-AZ in an auto-scaling group as well. And then below that, the last item, we have the RDS multi-AZ PostgreSQL instance. Of note is in the upper left, we have this Lambda function and a DynamoDB table. This is important to call out because this is how the whitelisting that allows agents ability to come in and actually access the Puppet Master catalog compilers. Without that, there's no access to any of the system. You'll notice that on the right, we have these 3 small representations of applications, and these would be like just an example of 3 different applications that are running this solution. Each of those has that same Lambda function and has to be able to connect back and talk to the Puppet Master, so that's a critical component. The next slide will actually we'll dive into that whitelist process a little bit deeper so you can see how that works. In the upper left, we've got what would be just EC2 instances, Puppet agents that need to be able to connect and talk to the Puppet Master service. So in order to do that, they go outbound through their public IP, their gateway address, whether it be a NAT or if they've got a public IP assigned to them. It goes out, hits the Puppet Master ELB. That is running it's running an ELB with SSL TCP pass-through on port 8140, which also has proxy protocol enabled. So any incoming traffic, that IP address is then added to an X-forwarded for field, and that is passed along on the back end to an HA proxy listener that reads that public IP address out of the X forwarded for field, and if that address matches the whitelist, then it's passed through. If it doesn't, then it just dumps the traffic. If it passes it through, it strips off the proxy protocol preamble and passes it along to the Puppet server running on TCP 8140. Then the Puppet master server determines whether that certificate's agent is valid or not and goes through the process of a catalog compile. The whitelist updater is just a simple script that runs continually on the box that checks for any changes to that DynamoDB table, and then if there's any change to the resulting whitelist, it updates it, and those changes are taken dynamically. In addition to that, over on the left, we have that Puppet census Lambda function that basically does three things. It assumes an IAM role that's in the Puppet master account that has access to the DynamoDB. Then it uses the EC2 API to find any public IP addresses or EC2 instances, and then it does an update to that DynamoDB table if there are any changes that need to be made. That is it in a nutshell for that. The next thing I'd like to do is go ahead and cover the demo. So let me switch back over here. Okay, so as you can see, our stack finished launching. You can take a look at EC2 and refresh and see that we have instances running. And if we take a look at our load balancers, we'll see, oh, you know, I usually don't use the console. Things like a governor just slows you down. Where is that thing? You know, Nolan, how to move that? It's missing the, it's missing that little icon that allows you to shift the size up and down. Okay, there we go. Must be some glitch in Chrome or the console. All right, so we've got our load balancer. Let's go ahead and pull that up. And you can see we've got just a blank canvas. We've got an Apache web server running with nothing in it. So if we want to deploy some code to that, we just need to go over to S3, access one of our code deploy buckets that just got created with the CloudFormation stack. Do an upload here. Okay, and we're going to grab this bucket name. Let's just try that. Huh. Let's try copying it the old-fashioned way. Okay, and then if we go over to code deploy, refresh that because it's on the introduction page. We can see we have a application that's been created here. If we click on that, we can see that we have a deployment group. We can highlight and create a new deployment revision. And these are already pre-populated with our application and deployment group. Since we're loading the package from S3, we'll put in that. Put in our file name. Now as we tab down, we can see that it automatically recognizes the S3 resource. It saw it, it has access to it, and it tells us the revision ID. And then we can just say deploy now. So as this is deploying, it's pretty quick, but we can just click on the deployment ID and view the events and watch it happen. Hit refresh a couple times. Okay, so it's done. If we switch back over to our ELB now and do a refresh, we will see that we no longer have a blank page, but an application. So you can basically take this solution and go from nothing to a fully deployed application in like a 15-minute time period, assuming you have your code packaged and ready to go. It also integrates great with things like continual integration and continual delivery. With that, I'm going to turn it over to Resh, and he's going to wrap things up. Thank you.
Thanks, Ryan. Are we here? We back? All right, we're back. Excellent. So really, you know, when you saw the lift and shift migration piece, and that's the easy part. When you start getting into the complexities that Ryan just went through and Chris went through, which is the cultural shift to DevOps and the actual technical pieces of Puppet and all of its friends out there and all those tools, there's a lot of complexity out there. So we see that, you know, make it easy. When you talk to your CEOs, your CIOs, and others, you know, they're interested in two things, right? It's cost containment and digital acceleration. How fast can we get products out? So these are the tools that we just showed that will help you do both of those. You know, what we will, you know, what you will notice is that this whole change continuum, this is going to evolve even further. Next year, there'll be another talk here about, you know, using some other tool to do this and get there. But it will always come down to increasing profit, cost containment, and getting to market faster. We have a couple of minutes. I think we could do Q&A if you'd like. If not, we're available after this, and we are in booth, what number is it? 825 on the floor. We'll be here all week. We have a lot of folks here, so if you're interested in talking, you know, we welcome you to do so. But really appreciate your time today. And if there's any questions, please, I think we have a mic here, so we can dive in. Anyone? All right. Thank you. Thank you. Any questions? Going once. Going twice. All right. Thanks, guys. Have fun at Vegas. Enjoy reInvent.